Okay, what we are going to talk about over here now, it is essentially speaking about what is called a high voltage DC transmission system. Okay, now after studying this unit, you should be knowledgeable about the West Core project, the HVDC transmission lines in Africa, the advantages and disadvantages of HVDC transmission as compared with HVAC transmission, and the three different types of HVDC links. More specifically, you should be able to do the following now. Sketch a simplified diagram and explain the functional operation of the three types of HVDC links. Okay, sketch the basic topology of a converter terminal, graphically derive the voltages and currents present in a converter terminal, determine the RMS value of the currents present in the various components of a converter terminal, determine the frequency components present in the phase and the line currents on the AC side of a converter terminal, and then also sketch the harmonic profile. Determine the total harmonic distortion, also known as THD. Determine the input distortion factor known as DF. Calculate the input power factor, also known as PF. Right. So just a brief introduction. Right. Have you ever wondered why the conventional way of transporting electrical energy is AC and not DC? Edison used DC transmission in New York between 1860 and 1890. The high current causing losses in the conductors necessitated that generators had to be set up and installed in every city block to keep the voltage drop in the conductors to an acceptable limit. In those days, there was no means of stepping the DC voltage up to the high voltage to reduce the current and thus the losses, and then to step the DC voltage down at the end user. Then Tesla introduced this three-phase system with step up and step down transformers. This meant that electrical energy could be generated where there was an abundance of natural energy resources such as the Niagara Falls. Okay, and then it stepped up to a high voltage, simply meaning a low current, and then transported over hundreds of kilometers, and then step down to a low voltage with a high current at the load demanded. Okay, DC distribution of electrical energy did not make economic sense anymore, and therefore it was abandoned. Right. However, technology is always evolving, and what may not be economical or viable today may become economically viable tomorrow. In the 1920s, it was recognized that there were applications in which HVDC transmission had advantages over HVAC transmission. However, there were no high voltage devices available for the conversion of AC to DC, and vice versa. The first commercially viable long-distance DC transmission was done in 1954 in Sweden by using high-voltage mercury arc valves. Okay, it was called the Gotland project. It was 100 kV, 20 megawatts, 98 kilometers submarine cable. Okay, in the 1970s, the thyristor valve was used in a HVDC application, and since the 1990s, the IGBT valve was found. It has found applications in HVDC applications. Okay, a valve is a term used in HVDC applications to indicate that many devices are connected in series and parallel configurations to achieve the desired voltage and current ratings. In this study unit now, we will explore the types of HVDC systems, the history, the advantages and disadvantages, the African HVDC links converter station topology and analysis involving currents encountered in a converter station and the power lines feeding it. HVDC is not the most widely used method of transmission when it comes to electrical power, but it has its own peculiar applications or application scenarios where it is more cost effective than HVAC transmission. It is slowly gaining more and more application as the transmission voltage, okay, as the transmission voltages and the distances between converter stations are increased and the relative cost of converter stations become less in real terms. In the African scenario, HVDC offer advantages over HVAC systems due to the following. Okay, and this is key. In the African scenario, HVDC offer advantages over HVAC transmission due to the following. Right, now here we go. There are often large distances between generating facilities and larger consumers. So simply meaning there are often large distances. Okay, so this is an advantage of HVDC over HVAC transmission. There are often large distances between generating facilities and large consumers. Okay, in many cases there is cross-border transmission, sometimes multiple cross borders. Okay, Africa is divided in French, Portuguese, and English speaking countries, simply meaning you have what? Language barriers. Okay, a complete chapter here is dedicated to HVDC, but due to the changing nature of technology, international politics, as well as economics and information presented in any book may quickly become outdated. However, all right. However, having said that, certain basics will stay relevant, such as the three basic types of HVDC transmission, the basic topology used in the converter stations, the typical wave shapes encountered for voltage and current, the fact that harmonics are being generated by the converter stations and thus feed the need for line traps, series resonant filters on the DC side and filters on the AC side of each converter. The technology that is continuously being improved is that of the electronic semiconductor devices used in the converters. The voltage withstanding capability and current handling ability of newer devices are improved over time, leading to periodical refurbishment of the converter stations. New HVDC lines also utilize the latest available technology. Right. The voltage withstand capability of devices having improved tremendously over the current handling ability has also improved. This means that less series strings are required in the valves for a given maximum valve current. The original Cahora-Bassa Gauteng HVDC scheme built in the 1970s had 46,000 thyristors. A thyristor is the family name given to devices that were known as silicon controlled rectifier SCR. Okay, the latest refurbishment of the Apollo station 2006 to 2009 has replaced the 25,728 thyristors with 1,728 thyristors. The old thyristors were 900 amp devices and the new ones are 3,300 amp devices with an 8.5 kilovolt rating. Previously, 280 devices were required in series to achieve the 133 kV rating. The previous or the valve rating is currently 3,300 amps, 1,133 kilovolts. Fewer components leads to improved reliability as well as lower costs. Right.